So here we go, 8-2. We're going to do all of 8-2. I hope it's not too long. This chapter in your book is circles and ellipses, but I'm just going to focus on ellipses. We did some circles when we did polar graphing, so I think we're okay. Ellipses. All right, so if you've ever studied conic sections, you probably know what an ellipse is. It's an oval, okay? So let's go ahead and start with an introduction into what an ellipse looks like, its equation, all that good stuff, okay? All right, so first of all, the equation of an ellipse is this. X minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, it's a lot, right? I know. I'm actually teaching this lesson to my Algebra 2 kids today. So it was a whole year ago or less that you learned this stuff. All right, so what are all these things? So here we go. First of all, the center of your ellipse is HK. So if we're centered at the origin, it's just going to be x squared and y squared up top. But if you have moved away from the origin, then your ellipse will have some numbers up top in parentheses, okay? So here's what you do. We're going to graph it as we go along. You go out to some point, HK. Okay, there's HK. There's our center. And then what you're going to do is you're going to go a distance of A in each direction, left and right. Okay? And I'm going to say here that A is bigger than B. So I go a distance of, I think I'll change colors for you. This is A, and that way is negative A. Distance from the center, and you put 2 dots. Okay? Then you go up and down a distance of B, and you put 2 dots there. B, negative B. From the center. Everything comes off the center. That's the most important part. And then what you do is then you draw your ellipse, which is an oval shape. If A and B are equal to each other, then we have a circle. Okay. Then there are 2 very important points on the ellipse. So if you are going A is bigger than B, then your ellipse or your foci, they're called foci, will be on that side, okay? So that would be F1 right here and F2. I'm going to write this down just a minute. And then from the center, that right there, out to your foci is a distance of C from the center. Okay? Zoom in a little bit. That's a lot. Do you remember this? Yes? No? Maybe so? Okay, so let's talk about this. We're going to say that so let's say that A is bigger than B. If A is less than B, then everything just gets flipped the other way. Okay, everything just kind of changes. All right, so we have something called the foci. The foci are those 2 nails in the board that I showed you. And the foci are going to be at the point, in this case, they would be at the point H plus or minus C, comma K, if A is bigger than B. What that means is from the x value of your center, you would go a distance of C in each direction. Now, how do we find C? C is found by doing C squared equals A squared minus B squared. Okay, that's when A is bigger than B. Now, you have vertices. In Algebra 2, you had vertices and covertices. In this book, you only have vertices. They don't call the other things covertices for some reason. I don't mind if you call them that. It doesn't bother me. The vertices are also going to come from HK, and they are distance. In this case, since A is bigger than B, your vertices would be at H plus and minus A, comma K. Okay. All right. Then you also have something called the major axis. The major axis is the longer axis. It's major. And in this case, the major axis is 2a. The length of it is 2a. A that way, that makes a total length of 2a. And then the minor axis is the shorter one. Okay? And that would be at 2b. Or not 2b. You know, you have to say that. It's stupid. Okay. What else? Anything else? Am I forgetting anything? Now, if B is bigger than A, then pretty much everything gets switched, okay? Your foci, here, let's do a little, Your foci would be then at H, comma, K plus or minus C, okay? Your vertices are now going the other direction. Remember, everything's from H and K. So this would be H, K plus or minus B would be your vertices. The major axis would be 2B, and the minor axis would be 2A, because it's shorter now. Okay, everything just gets switched. And then for the foci, it would be C squared equals B squared minus A squared. Those get switched too. Everything just changes, okay? I hope you remember some of this. If not, that's okay. I just taught it to you again. All right, let's try some. Here we go. You ready? We got all our information. I hope that's everything. Did I miss anything? No? I said if A equals B, it's a circle. Okay, we're good? All right, let's do it. Here we go. Part B. All right, there's really, like I said, two types of problems here. You are going to be given an equation and you have to find out stuff, or you're given some stuff and you have to find the equation. So let's start with given an equation. You're going to graph and find the parts. Graph and find all the parts. And then in part C, we'll go the other way, okay? All right, let's start easy, then we'll work our way to like the most difficult. Number 1, here we go. Suppose that you have 4x squared plus y squared equals 36. And we have to find the center, vertices, major axis, minor axis, foci. You gotta do the whole thing. This is like a 10-point problem on a quiz. It's crazy. All right, first step. This does not look like our normal ellipse equation, right? We want it to equal 1 over here. So let's go ahead and take 36 and let's divide all of our terms by 36. Now, I like to give you really good numbers, especially when you're doing these. I like to give you perfect squares. So just be prepared for that. All right, so we get x squared over 9 plus y squared over 36 equals 1. All right, now we're ready to do the whole thing. Okay, center. So let's go like this. We'll go the center, vertices, foci. Is that it? Center, vertices, foci, and the graph, of course. Ooh, major axis, minor axis. Just preparing you for what you'll see on the quiz next week. All of those things for one problem, okay? All right, so here we go. Center. Center is going to be for this one. There's no H or K, so that would be 0, 0. So the center is at the origin, or you could write 0, 0. So everything's going to come from 0, 0, okay? Making it easy on you. What's so funny today? Nothing? You love this, huh? You like, yeah, that's it. Okay, good. All right, so here's the center, and I'm going to go a distance of 3 in each direction, left and right. See that 9? In the equation up here, it's a squared, but I go a distance of a in each direction, so I have to take the square root. That's why I like to give you perfect squares for these. All right, so I go 1, 2, 3, and I put a dot, and 1, 2, 3, another dot. And then I'm going to go up and down a distance of 6. 1, 2, 3, 4, 5, 6. Do you guys remember these at all? A little bit? No? Okay. 1, 2, 3. Hey, weren't you in my class? No. Cowie?
No.
Bexford? Algebra 2? Me.
I think it was you.
I think it was me too. Yeah, you should remember this. I taught this to you last year. You're like, nope. Okay, all right, you're right. Okay, Here we go, 6 up and down, and then don't forget to draw your graph. A lot of people will plot those points and they forget to like complete it. It's kind of funny. I get that all the time. It's not funny, but you know, it's like, why didn't you graph it? Okay, it is sad. It's not funny, it's sad, terribly sad. All right, so our vertices. The vertices are the farther ones away from the center, and those vertices, I just put them in blue, they are right there, and you can write them like this. They're at 0 plus or minus 6. Do not switch those, do not get those mixed up, okay? There's an x coordinate and a y coordinate. It's very important that you don't mix those up. All right, the foci are found by doing c squared equals. And here's where people are like, oh, I have so many things to memorize. Well, you just need to remember it's bigger minus smaller, okay? So 36 minus 9. Because people are like, is it a squared minus b squared? Is it b squared minus a squared? It's just always the bigger one minus the smaller one. So c squared would equal what? What is that? 27. Take the plus and minus square root. Don't forget to rationalize. I make the Algebra 2 kids do this too. They get kind of mad at me. So this would be what? 3 rad 3? 3 rad 3. Okay, now the foci are not plus and minus 3 rad 3. The foci are points on a graph. And points, as you know, have an x and a y coordinate. So then you have to decide, well, where are they going to go? Are they going from the center? Are they going up and down or left and right? Well, the foci are always on the longer, they're on the major axis every time. So the foci would be at 0 plus and minus 3 rad 3. All right, now we have the major axis. The major axis has a length of what? 12. See, and you don't have to memorize, like, is it 2 times b? Is it 2 times a? Look at your graph. That's the best thing. You have it graphed, look at it. And then the minor axis goes side to side, which is 6. Yay. Okay. So that was centered at the origin. Those are usually tend to be the easier ones. That was your basic Algebra 2 problem. All right, the next one's going to be an Algebra 2 type problem too, but we really need to warm this up and do this one too. All right, so I'm going to move it. I'm going to move the center from the origin. Don't forget everything comes from the center, okay? So this is x minus 2 squared over 25 plus y plus 3 squared over 16 equals 1. Okay, so we're going to do the whole thing. We're going to graph it. We're going to say what the center is, the vertices, the foci. Sometimes they might not ask for the major. Let's just do it one more time. Oops, the major, come on, and minor axis. I need a new stylus. And a new stylist. The Sam Club clothes are not really happening. Center. The center is at 2, negative 3. Okay? So everything's going to come from there. 2, negative 3. I go positive 2, down 3, and we'll put a dot. All right. So from that dot, we are going to go left and right a distance of 5. Yes. So you go 1, 2, 3, 4, 5, and you plot your point. Ooh, I'll do this in blue again. And then we go, we're at 2, right? Yeah. 1, 2, 3, 4, 5, and we go over here and plot a point. Now, if you don't like to count or figure out where that's at, okay, all you have to do is from the center, add 5 and subtract 5 from 2, right? It's coming from the center and it's x, the x this way, horizontal, so we're going this way 5 and that way 5. So we get 2 plus 5 is 7, negative 3, okay? And then 2 minus 5 is negative 3, negative 3. Or if you are a visual person and you see that you have graphed this point right here is 7, negative 3, and this point is negative 3, negative 3, then you can do it that way too. All right, the foci, oh, I haven't gone up and down. Then we have to go up and down a distance of 4. That comes from this 16 right here. So you go 1, 2, 3, 4. And they don't ask for those points. 1, 2, 3, 4. And then don't forget to actually draw in your graph. Those would be considered the co-vertices from Algebra 2, but this book, they don't care about them. Okay, you can right now, we can do the major and minor axis if you'd like to. The major axis is the longer one, and that has a distance of 5 here and 5 this direction. So that would be 10 for the major axis. And then the minor axis is up and down, so that would be a length of what? 8. Good. Okay, now we need to find the foci. Don't forget the foci are going to be a distance off the center also. So we're going to do c squared equals big number minus small number. Okay, c squared equals a squared minus b squared this time. So c squared equals, oh, does that turn out nicely? Yeah, 9? So c equals plus or minus 3. All right, so our foci are going to be from the center, plus and minus 3 horizontally. So from the x value of the center. So if I were going to say what my foci are, they would be at 5, -3. Okay, so from 2, from this 2 right here, I have to go a distance of 3 in each direction. There's a foci. And 3 in that direction, there's another one. So what was it? 5 minus 3, -3. And then the other way would be -1, -3. Okay? Some people along the way, they like to leave it as like 2 plus or minus 3, -3. And that's okay. I'm okay with that. I just think it's kind of lazy, but whatever. All right, here we go. We're going to do one more. This one's a little tricky. So this is not an Algebra 2 question. This is a ham question. So number 3, last one of this section, and then we go to the other types. Maybe I'll give you a little break in the middle. All right, we are going to write a standard form for an ellipse. Okay? And then I'll just stop there, or we can find the vertices and all that stuff from it too. Okay, here we go. You have x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. All right, does that look like an ellipse to you? It doesn't, right? It is. It's an ellipse. I'll tell you why it's an ellipse. It's an ellipse because both the x and the y are squared. Okay, that's one way. Because remember, a parabola, only one of them is squared. And the coefficients are both positive. It's 1x squared and 4y squared. That's why it's an ellipse. They're positive, and they're not equal to each other. If they were equal to each other, it'd be a circle. All right, so here we go. You know what we're going to do? We're going to complete the square twice. Isn't this so good? All right, here we go. So we have to get these into their perfect squares and for both x squared and for y squared. So here's what you want to do. You want to get the x's together. So we have x squared plus 6x, okay, plus blank. That's going to be the perfect square trinomial for the x's. And then the y's, what you're going to do, you need to factor out the 4, okay, and you'll get y squared minus 2y plus blank, okay. Everyone following that? So I put the x's over here, and I put the y's over here. We're factoring out a 4. And then let's go ahead and subtract the 9 to the other side. Get our constant over. Did you guys do this in HAT last year? You did? Okay. Algebra 2 did not. So, okay, here we go. We're going to complete this square twice. So let's work with the x's first. We're going to take half of 6, which is 3, and square it. So we're going to add 9 to both sides. Okay? Add 9 to both sides. Then we're going to take half of -2, which is -1, and square that. And so we're going to add what to both sides? 4. Remember? You have to like distribute in your mind. It's really, we just added 4 to this side, so we have to add 4 to that side. Okay, hard part's done. Let's go ahead and put this in a perfect square trinomial. So this would be x plus 3 squared. It's always just half of b, plus 4 times y minus 1 squared. So half of -2 is -1, equals 4. All right, one last step. We're going to divide everything by 4. See this? I want my ellipse to equal 1 over here. So we're going to divide everybody by 4. And what we get is x plus 3 squared over 4 plus y minus 1 squared. That's just over 1. See how the 4's will reduce? You could put it over 1 if you want to. And then it equals 1. So that would be standard form. I think I would probably put that over 1 just so it looks like a little bit better. Okay? And then you can get everything from there. I don't know if we need to do that. Do you feel like you would be capable of doing that? You could get the center, go 2 in each direction, left and right, 1 up and down, find the foci. Okay, I think so too. All right. All right, last part, part C. Oh, that's so much better. Okay, now we're going to find an equation. Find an equation for the ellipse. So I'm going to give you some pieces of information, just enough, barely enough to get you to find the equation, okay? All right, what was that? That was 3. Let's do it. Number 4. All right, suppose that we are given, here's an easy one. Here's a nice little warm-up. Suppose we're given a picture of an ellipse. It looks like this. 1, 2, 3, 4, 1, 2. Okay, there you go. And it just says, here you go, here's an equation, or here's a picture of an ellipse. It tells you that the y-intercept is 0, 4, the x-intercept is 2, 0. It gives you a picture of it. It says make an equation. Okay? So your basic equation is that x minus h squared over a squared plus, it's always plus in the middle for an ellipse. And then let's go from there. All right, so we could tell right away the center's at the origin, right? Everything's coming off of that. Nice and easy. So we'll go x squared plus y squared equals 1. So there's your basic. Put the center in, 0, 0. So it's just x squared and y squared up top. Left and right is a distance of 2. We square that number and write 4. Up and down is a distance of 4. We square that number and write 16. All right. So you feel like I'm insulting your intelligence, right? You feel like, oh, that was way too easy. And it was. It should be way too easy. Okay. We got to do some easy ones. This class can't all be hard. All right, let's do this one now. Here we go. They tell us that the foci are located at 0, 1, and 4, 1, and that the major axis length is 6. And we have to, just from that, find an equation of an ellipse, okay? All right, now, my suggestion to you, whether you take it or not, you should, is to draw a picture of this, okay? It'll really help. When you see things visually, it really helps you with these. So let's go ahead and put our foci in. So I have foci, 2 points. I know how to plot 2 points. We have 0, 1. It's right here, right? And 4, 1. 1, 2, 3, 4, 1. So there's our foci. All right, knowing that right there, that tells us what the center is. It's directly in the middle of those, right? So the center of this is going to be right there. So distance of 2 that way, distance of 2 that way. Everything's so symmetrical on these things. They're really, really pretty. Okay, so there's our center. So our center of our ellipse is at 2, 1. Is everyone okay with that? Yeah, I'm doing this right? Okay. All right, and then it says the major axis has a length of 6. That's the entire axis. Now don't forget, we're always going from the center. So we would go how far each direction? 3, yes. We would want to go out here 3 and 3, okay? And I drew it that way because the foci are always on the major axis. So I knew I had to go left and right instead of up and down. All right, so I have some information. I'm now going to go to my equation and put the stuff in that I know. I don't know how far up and down yet, but I can figure that out in just a minute. All right, so here we go. We're going to write x minus 2 squared plus y minus 1 squared equals 1. So you'll get points, whatever you can do. If you mess up on the whole thing and you put the center in correctly, you'll get some points for that. Okay, now from the center, we said that left and right was a distance of 3. So what are we going to write right here? Perfect, 9. 3 squared. All right, now we have to find out what b squared is. And I haven't really used the fact that the foci are 2 away. And by the way, anytime they give you the foci as part of the stuff that they give you, you will use the foci equation. In this case, the foci equation is c squared equals a squared minus b squared. It's longer this way than it is that way, okay? All right, now we know these numbers. We can put them in and solve for b squared. That's what we're trying to find is b squared right here. So what is c? C is the distance from the center to our foci, and that was a distance of 2. So 2 squared is 4. A squared is 9. B squared is our question mark. Subtract 9 to the other side. Negative 5 equals negative b squared. So b squared equals 5. There's no need to take the square root. That's what we're looking for, and that's the equation of our ellipse. Just finding the equation, okay? Yep, you did that last year. You did. And you hated it. All right, number 6. Okay, let's say that, oh, that's probably the hardest one. Okay, that's cool. All right, let's say that the vertices are at 4, negative 4, 4, 4, and that our ellipse goes through the point, 7, 0. 7, 0. Okay? All right, we're supposed to come up with an equation for the ellipse. All right, so like I said, draw a picture of this. Okay, you're given 3 points. Let's go ahead and plot them. So vertices, they told me, are at 4, negative 4. So there's 1. There's a vertex. And then at 4, 4. So 4, 1, 2, 3, 4. Right there. Okay? They also tell me that it goes through the point 7, 0. So 4, 5, 6, 7. So here's what our ellipse looks like. 7. Let's see. That's going to be the center. 1, 2, 3. 1, 2. It's going to go through there. There we go. A little lopsided, but that's okay. And you know what? You have everything you need. There's no foci involved. You don't have to use the foci equation. You can just look at it. And so what do we have? We have a center, and our center is at 4, 0. Okay, it's right in the middle of these. See how the x doesn't change? And then for the y, it's directly in the middle of negative 4 and positive 4. So you take the average if you want to, if you can't see it on your graph. But it was 4 going up and down, so in the middle would be right there. And I try to make those numbers even so that they divide nicely when you're trying to do these, okay? All right, so here we go. We've got x minus 4 squared plus, you don't want to write y minus 0 squared, just write y squared equals 1. And then, as you can tell, because of this point they gave me, 7, 0, this is the distance of 3. You see that? You just graph it. You see it. So you get 9 here, and the distance up and down is 16. Now, are you kind of asking yourself what would have happened if they gave us a point out here, right? Like not 7, 0, but whatever point that is. You would then have to plug that point in for x and y and then solve. It's a little tricky. Just to warn you, you might have one like that. I don't know if that was like a bonus type question though. Okay, and the other one I have is just kind of like the one I gave you at the beginning. So I think you're pretty good. I think we're good to go. All right,